Maximum production output is a great experience and a worthwhile goal. The downtime, however, is keeping you from having that experience or reaching that goal. So knowing what is causing the downtime allows you to fix the problem, but you need insight in order to do that. So this video will show how Power BI is used against downtime data to gain the insight needed to reach your production output goals. So I'm starting with this downtime reason by minutes, team, and location page to give you some real quick insight into what's causing downtime and where it's coming from. So for the week of September 2nd, you can see that other categories was the #1 reason that you had downtime, followed by other, supervisor problem online, all the way down to wrong stock, high-low as the reasons. You can also see down here how the various teams perform. So team 1 had the most amount of downtime, followed by team 4 and 5, all the way down to, it looks like team 6 had the least amount of downtime. So some useful insight into the week for team and downtime reason. You can drill into a particular day or even a particular minute and see how things were going at that time. So on September 3rd, which was Tuesday, we can see that tool down maintenance was the #1 reason for downtime, and that team 5 had the most amount of downtime. But team 5 may not have had tool down maintenance as the #1 reason, but in fact it did. Oh, I'm sorry, no it didn't. Not entered or expired is the #1 reason for downtime. So some quick insight into where the downtime is coming from a team perspective and a reason perspective. Now if we go over to this tree map, we can again look by day and start drilling in to see more useful information. So again, team 1 had a lot of problems at this frame C1 location. So what's going on there? Well, I don't know. Let's drill in and find out. So other categories again, not that helpful, but tool down maintenance is the second reason for downtime, and that's something you can do something about. Finally, we have this stacked bar chart that shows planned and unplanned downtime. We could drill into again, but you can see at a glance, red is bad, black is good, so you know, well, black is better. No downtime is best, but you can gain some quick insight into planned and unplanned downtime. Finally, two last things we want to look at: the overall trend for the week. The overall trend was positive. Downtime went down from about 225,000 down to about 175. So that's a great thing. And lastly, we can look at units built and lost and units built and lost by hour. So here's for the week. We can see that the 5th was where you had the most amount of output from a units perspective, and you made 83. You could have made 25 more, but there were reasons that didn't occur, and you can look at those reasons by going back to the other charts, the other pages that we just took time looking at. And by clicking on the 5th, we can see the day by hour what was going on. So 7 o'clock, only 4 units were made and 8 were not. So that was unfortunate. And then we see at 8 o'clock and at 2 o'clock maximum output was reached. So that's great. 11 o'clock wasn't bad. Noon was pretty darn good as well. So some quick insights into your data. At this point, what was going on at 7 o'clock in the morning on the 5th? That's going to give you some idea on why you lost 8 units, why 8 units weren't built. What happened from a team, location, reason perspective. And by going back into these areas, we can figure that out. To the point, you could, if you wanted to, see the records or show the data that is under the hood of all of these visuals that we're looking at. You can even export this to Excel. So some great ways to see how your downtime data can be leveraged to really help you understand where downtime is occurring and then what you can do to fix it so that you have the least amount of downtime with the most amount of production output. Next, I'd like to show you the smartphone application used for recording information. I don't have a downtime reporting application built, but I do have a gauge calibration app built, so I recorded a video of that. I think you'll get the understanding and be able to make the connection between what you're seeing and what would be required for downtime reporting. So in this case, I'm opening up the gauge calibration app, and it's loading the data. So I'm going to add a record by clicking the plus, and here we go, just using the keypad on the phone, entering serial number. Once I do that, I'll enter department, and then we'll move into some drop downs which contain values for various options like frequency or gauge type. I'll make those selections, choosing surface plate. We have a date picker, so it makes it easy to choose dates. Once I'm done clicking or selecting all these fields, and I'll click the check mark at the top to save the record, and it will write back to the course system. And now I'm scrolling down to show you that the record was in fact saved. So we're looking for DC 351. There it is. I'll drill into it to see all the data that we entered. At this point, I could delete or edit that record or just go back to the core list. That's really a pretty straightforward representation of what the smartphone application for downtime reporting would look like. I hope the video on the smartphone app, as well as the video regarding Power BI and all of its reporting capabilities, really help you understand what's possible within your existing environment and what we can do to help you reduce downtime. Thanks.